As we have seen in previous videos, the syntax of the Internet of Things and the anatomy of smart objects allow for much more complex use cases than those commonly known as smart cities, in which objects just send sensor data to information systems. Some examples are self-driving cars, service robots, smart luggage, or thermostats able to predict the behavior of a person living in a house. A syntax with 3 entities and 9 relationships allows from very simple to extremely sophisticated use cases. Since these use cases vary so much in complexity, we propose a classification, a taxonomy of the different use cases in the Internet of Things. This proposed taxonomy consists of 7 different levels, going from the simplest to the most sophisticated use cases. In level 1, we include use cases in which objects simply sense and supply data to an information system. Temperature sensors, light sensors, traffic sensors, parking sensors, they all fall into this level of the taxonomy. The second level use cases are those in which, instead of only sending data, the smart object is able to pre-process this data and turn it into events. For example, a smart lamp post in the street, which has an audio sensor, may also have the processing capability to determine whether this audio corresponds to a gunshot. So instead of sending just the audio stream, just the data, it sends the event that a gunshot was fired in the proximity of the object. That would be level 2 in the taxonomy. Now, when in order to process and decide, the object needs to receive information either from people, from information systems, or from other objects, when the object is exchanging information in 2 directions, then we classify these use cases as level 3 in this taxonomy. Level 4 are the use cases in which, using information retrieved from outside, together with information that has been gathered by itself, the object is able to make predictions. For instance, in level 4, we would have these smart thermostats that sense the temperature, sense the HVAC system performance, but also gather information about the location and habits of the people living in the house and the weather, and are able to make predictions of what will be the best way to regulate the HVAC system for maximum comfort and minimum energy use. These are the kind of use cases in level 4. In level 5, we place the use cases in which the smart objects, using their capabilities of interacting both with the digital and the physical worlds, take action. And when a smart object takes action, it not only makes a prediction, but acts on that prediction and modifies something either in the digital world or the physical world, or in both. In level 5 of this taxonomy, we have smart objects that are not only reactive, but also proactive. Next, level 6 are use cases in which a smart object not only takes action, but when these actions are directed towards fulfilling a goal. Examples of goals are to save energy, to save money, to create a comfortable atmosphere, to keep a safe environment, or a smart robot used during an operation on a patient. All these goals require a set of actions, so the actions are not isolated, but they are combined in order to fulfill the goals. Finally, the most sophisticated, the most advanced level of smart objects in the IoT are level 7, in which smart objects behave as members of a team composed of any combination of other objects, people, and information systems. When in order to fulfill its goals, the smart object needs to cooperate with other entities, then we are in level 7, the highest possible level of the Internet of Things use cases. And we will see very soon such use cases in action in real life.